Course name Mathematical Physics 2, MSc second semester, Punjab University. Video lecture delivered by me, Arvind Chauhan, Assistant Professor, Department of Physics, SVN College, Mukeria, Hoshiarpur. Today we are going to discuss about the convolution theorem for Fourier transform. Basically, the convolution theorem of two functions, one of f of x, another one g of x, is defined as in the interval between minus infinite to plus infinite in this form is here. F of x convolution g of x is equal to minus infinite to plus infinite f of u g x minus u du. The integral of this portion will be h of x, means when you are going to integrate f of u g x minus u with respect to u, you will get a new function, that is a function of x represented by h. This is the way of defining the convolution in between two functions. This symbol is basically a convolution symbol. F of x is a function, one function, and g of x is another function. Now, convolution theorem. This theorem is important for your exam point of view, can be asked in your university exam. The Fourier transform of convolution of f of x and g of x is the product of their Fourier transforms. Basically, statement of the convolution theorem is the Fourier transform of convolution of f of x, one function, and g of x, another function, in the product of their Fourier transform. Mathematically, we can represent this statement in this form. Fourier transform of f convolution g is equal to Fourier transform of f of x times Fourier transform of g of x. Here we are going to prove this result. For proof, we know that, as I told you in previous classes, the Fourier transform of any function f of x can be represented minus infinite to plus infinite f of x exponential iota sx dx. This is the representation of Fourier transform of any function f of x. Then, with the help of this formula, if we are going to write the Fourier transform of f of x convolution g of x is equal to basically minus infinite to plus infinite, same is here. Exponential iota sx is here, and here is what? Basically, here is the, at the place of f of x, we are going to write this result, because f of x time convolution g of x, f of x convolution g of x, basically this. So we are going to write here minus infinite to plus infinite, f of u, z of x minus u, du, f of u, z of x minus u, du. Basically this is a representation in between two functions convolution, du dx. In next line, minus infinite to plus infinite is same, minus infinite to plus infinite again same. You have two integrals here, and you are going to put this part exponential iota sx inside here, f of u, g u minus x, du dx. Now as you see here, the limits of both integrals are same. Then we can change the order of the integral. Changing the order of the integral minus infinite, because if the limit of the two integrals are different, then we cannot change directly the order of two integral. But here no problem, because limit of the both integrals are same, then you can change the integral order. You can do the integral dx first, then du after. Change the order of the integration, minus infinite to plus infinite, f of u, then bracket minus infinite to plus infinite, exponential iota sx, g of u minus x dx, bracket of du. Now now put x minus u is equal to t. So dx is equal to dt and x is equal to u plus t. Limits are, when x is minus infinite, the t is also minus infinite. When x is plus infinite, t also plus infinite. Then next phase, our what we are going to do here, we are trying to find out the Fourier transform of function f convolution z is equal to. So again, minus infinite to plus infinite, f of u is here, bracket minus infinite to plus infinite, exponential iota s x is how much? U plus t. U plus t is here, and u x minus u is basically what? T and dt, bracket of du. Okay. The next line, minus infinite to plus infinite, exponential isu f of u, bracket minus infinite to plus infinite, exponential ist. From here, when you open this, you have two terms. One is exponential isu plus ist. So you can represent this representation in this form: exponential iota s t into exponential iota su. This thing and this thing are same. So from here you can take out exponential iota su f of u, then bracket of minus infinite to plus infinite, exponential ist gt dt, bracket of du, minus infinite to plus infinite, exponential isu f of u du. This is the same, the integral of this is this, and minus infinite to plus infinite e raised to power ist gt dt. Now if we change the variable, if you replace u with x and du with dx and u with x, then no change in limit, you will get the same thing. Minus infinite to plus infinite limits are same. If you replace again the gt and this is basically what these two integrals are, basically nothing but these two are basically minus infinite to plus infinite f of x exponential iota sx dx, minus infinite to plus infinite g of x, it is exponential iota sx dx. By the property of the definite integral, if you change the variable, then limit cannot be changed, limits remain same, and the integral can be represented in this form. Or this is the representation of Fourier transform of f of x, or this is the representation of Fourier transform of g of x. So therefore our left side is this: Fourier transform of f of x convolution g of x is equal to f of Fourier transform of f of x times Fourier transform of f of g of x. This is a required result, therefore it's true. Now come to the next point. We are going to learn about some property of the Fourier transform. This also can be asked in your exam in short answer type question. In 5th unit, basically first property of Fourier transform is change of scale property. It's a well-known property. If f of x is the Fourier transform, f of s is the Fourier transform of f of x, then f of ax means if you replace f of x by some new function f of ax, where there x is just a times of x, then the Fourier transform of this function basically nothing but 1 by a f of s by a. So we are trying to find out this result, how this result is come. So for proof, so very first we are going to write the expression that is defined the Fourier transform. Basically Fourier transform of any function f of s is equal to Fourier transform of f of x is just equal to nothing but minus infinite to plus infinite f of x exponential iota sx dx. Okay, therefore in such a way the Fourier transform of f of ax can be written minus infinite to plus infinite f of ax exponential iota sx dx. put in this expression a of x is equal to t. So dx is equal to dt by a and x is equal to t by a. So f of ax, Fourier transform of f of ax is equal to minus infinite to plus infinite is same. Exponential iota at the place of x, put t by a. From here x is equal to t by a, then t by a, or f of ax is nothing basically f of t, or dt is nothing but dt by a. If x is infinite, minus infinite, if x is minus infinite, t is minus infinite. If x is plus infinite, then t is also plus infinite. Limits does not change. So next line, 1 by a goes out because it's a constant. Minus infinite to plus infinite. F of t is here. Exponential iota sya dt, sya times t and dt. This is basically again Fourier transform representation. As you know here, f of s how much? Minus infinite to plus infinite. F of x exponential iota sx. If s is here, then s is here. Now here sya is here, then sya is here. So therefore Fourier transform of f of x is equal to 1 by a f of s by a. So this is required expression. Thank you.